This first video, we're going to take a look at finding inverses using the idea of the principal values that we explored when we looked at the inverse function graphs. So just to recap from what we did with that, sine inverse and cosecant inverse are both going to have values that will fall between negative 90 and 90, or negative pi over 2 and pi over 2. Inclusive of those values, and then tangent inverse will also be negative 90 to 90. Since it's undefined at 90, we're not getting actual values for those spots, hence the parentheses. Now when we're choosing between the quadrants, because we're going to be going back to some unit circle stuff, we're looking between quadrant 1 and quadrant 4, but the trick with quadrant 4 is the angle value is going to be negative. Okay, and then the other three, the cosecant, inverse, and secant, and cotangent, are going to fall between 0 and 180. These ones are a little trickier because of that. In terms of, they're going to be all positive values, 0 to 180, 0 to pi. And cotangent has asymptotes, so that's why we're using parentheses on there. And then when we're picking values from our quadrants, we're going to be looking at quadrants 1 and 2 only. So you'll notice that we will never be writing down an angle for quadrant 3 here, and the 1 and 2 quadrant values will be between 0 and 180, so they will all be positive. Now, just to look back at something you did previously where we talked about principal values as opposed to solving equations, because we're going to be looking at the difference between both in this unit, the square root function is a good one to explore. If we ask you to find the square root of 4 in a problem, you would give the answer of 2. If we asked you to solve the equation x squared is equal to 4, you would take the square root of both sides to solve that equation, and there are two possible answers of 2 or negative 2. So when you're solving an equation, there is a potential for getting more values in the other quadrants. 2 is the principal value of the square root of 4. And inverse trig functions are going to have a similar result. If you're finding the inverse, you're just going to give that principal value. And we will get into solving equations after this, where you will get multiple answers, just like we did with this second one here. Okay, so because we're only looking at the principal values when we're looking at sine inverse, you want to think about your unit circle. So I would grab that out or draw one again. The value that goes with root 2 over 2 for sine is 45 degrees. Or pi over 4. Now we can put these in degrees. It doesn't really specify now until we get into composition. So what you want to think about is, okay, it's sine, the principal values for sine are either in the first or fourth quadrant. This one is in the first because it is positive. So we would put 45 degrees for that. Now the part B is going to be the same idea, but it's negative root 2 over 2. So that's going to be in the fourth quadrant. Now we want it to be between negative 90 and 90. So the difference here is that it's going to be negative 45. The temptation will be to put 315 for that, because that's what you're used to doing when we do the exact values. But now that we're going backwards, we have to make sure that it falls in these ranges up top here. Okay. Cosine is going to fall in two different quadrants. So cosine is going to be in the first and second quadrant when we're selecting for positive or negative. If it's positive, it's first quadrant. Inverse cosine of 1/2 is going to be 60 degrees. And again, you can use your unit circle for that. Remember, our main values that we're focusing in on are 30, 45, 60, root 3 over 2, 1/2, root 2 over 2 for both, and 1/2 root 3 over 2. So if cosine is our x value, that's going to be the shorter one for 60. And then cosine of negative 1/2, we're going to use the reference angle is 60. And then we're just going to use our rule for the second quadrant and do 180 minus 60, which will give us an answer of 120. So a little bit more work, because if it's sine or tangent inverse, you can just put the negative of that angle. So notice the difference between the two. Positive answer for that was 45, the negative was negative 45, whereas here it's 60 and 120, and you have to do that by calculating your 180 minus for that quadrant. All right, we have a few more to do for the inverses. Okay, tangent is just like sine. We're looking at first and fourth. Obviously different values. And if you're looking at your unit circle, one of your options is to write the tangent values right next to it. And then because we're looking at first and fourth, positive is first, negative is in the fourth, but again, it's a negative version of that angle. Tangent of inverse of root 3 over 3 is going to be 30 degrees. And then the other one will end up being negative 30. Negative 30 will be in the fourth quadrant. It falls between the range of negative 90 to 90. So that's your goal, is to make sure you're falling in that range that represents those principal values. Now cotangent is different. So although you might use tangent to help you figure out what the cotangent value is, cotangent is going to be like cosine, first and second quadrant. So first quadrant for a positive, second quadrant for a negative. So an extra little calculation here for this one. Inverse cotangent of 1, just like it would be for tangent, would be 45 degrees. And then rather than being negative 45 for this, you would use 45 as the reference angle. And you would do 180 minus 45. Shoot. Just erase that real quick. So that should be 135. Now you will probably have to complete these with different values, and your A and B won't be both of them. You might just have this or just have this, but I just wanted to do the first set as kind of a comparison. Okay, so again, if the problem asks you to find the inverse, it means to find the principal value. Okay, we're going to stop the video here and do another video for the composition of functions next.